Did a lot of building over the weekend. I did a lot of refactoring and just did a lot of cleanup. So one thing I did do, and I want to fix right now, is in our tests, we had our coverage set wrong. So it actually needs to be, it was set to test and just needs to be sources. And so we get a better readout. I knew something seemed a little fishy, like that our code coverage is a little too high, especially when I didn't test any of this stuff in here, all the tween stuff. So it's a little bit more accurate read, and I actually just added a few more things to ignore, like our constants doesn't need to be tested and stuff like that. So you'll see as this builds up. I also added it to our backend. So under our mix file, I added a library called xcoveralls that'll do our test coverage, and I also added dielixir. And with those, I needed to add a preferred CLI environment for coveralls. Just does a bunch of stuff for each environment, and then Dialyzer actually analyzes our code for static analysis. And so we get a lot of good stuff. So here we see that our coverage is pretty low compared to what it was at 68, which is pretty bad. I'm going to work on getting better. In fact, it's worse than it was. For some reason, I wonder if this test thing has anything to do with it. It says it's missing some packages. Let's run that real quick. So here, the dialyzer gives us a readout of how our code is, like almost like a secondary compiler. So I also fixed our tests. So if we run our tests, we'll see that this is weird. This is a transient failure. I think it's because we need to actually sleep in between. So I might actually just add that, and hopefully that's going to fix that problem. So I'm going to go to vi test game server. That's under the battle unit test. So models, battle unit test. Here, I wonder if we just add this. Let's say repo I wonder if we could do ss.exit repo. And see if that, oops. Yeah, it seems to be higher. I think the, I'm actually just going to take the test out. I don't want to be coordinating our tests. So it's even lower than I was hoping. So here this seems to be not breaking, and then we just run mix coveralls and we get test coverage out of that. So I want to spend a lot of time probably offline just fixing our test coverage. It's not that great. It's actually pretty terrible, and I just want a way higher. So this will build out here, and a lot of this stuff is like our tweening stuff. Like once I started ignoring some of that, our test coverage went much higher, but we need to have this tested. This thing here probably need to ignore cover on this. Wonder, let's see here, because we're testing threadedness. I don't want to have it being tested. Unsubscribed, animation managers test. For animation with events, I added that, and this isn't being tested. I just kind of roughed this in. This is kind of an easy fix. Anyways, so let's show you what I've been working on. So there's our test coverage there, and if you do mix dialyzer, it'll actually print out a bunch of warnings for our game here. But this is all stuff that we can fix, and a lot of this stuff is the logger actually. So we just fix how the logger is being matched. So we're going to get a lot of mileage out of this, and we're going to start tightening up our code and make things a lot better. But meantime, I want to show you what I've been working on. I've been working on a lot of stuff all weekend. So under lib on the game server, I created a couple of new modules, game server utils. This is just a macro, and so this will actually do all of our imports for us. Added some of these for our constants, our now, and our player server. That's stuff that we wanted to, that we're kind of reusing everywhere. So now with this, instead of having all those aliases, we just go over to here. Let's pick a better one. Let's go lib game server battle interaction unit interactions. So we just use game server utils, and all those aliases are in place for us. So that's going to save us a lot of effort there. Additionally, I created another, you'll see here, under the handler and the command handler, you'll see that I import game server commands. And you'll see now it says, instead of having those hard-coded numbers, we just have like unit created, unit moved, unit created, unit casting spell. So they actually act as constants. See, here's these constants here. And so what I did was lib game server commands, created a macro for each of those. So when I import these are actually executed at compile time, and that just returns 1, 2, 3, 4, etc. And so we've kind of dried out a lot of the pattern matching. And if we look at here, we have our lib game server socket acceptor. We do the same thing here. We're matching against these constants that we can. All we need to do is change in one spot. And lastly, game server handler output. If we just pick any of these, we'll do a unit created. You'll see that now we don't even return the constant, we just return this. We just import our game server commands, and then here we have our unit created command. So that cleaned up a lot of code. So that was really exciting. I also created one more huge thing, which is, I'll just show you. It's a lot more fun to show than to tell at this point. So we're going to do IEX mix game. One quick thing. Added a new task, which is seed, which will seed our database with some data. So I have 2 new unit stats, and then we have a spell, which is spawn minion. So IEX mix game server.start. There's our game running, and then if we run our game now, here's our guy. Actually, I added a auto connect, so we don't have to actually click and connect. That was actually pretty easy to set up. It's under our playground. We go here. We say whenever we get the current player, check to see if it's connected, and then we subscribe to connect and other stuff. So we say stream handler start, and then actually that'll run our connection, and then also on our close we can clean up our subscription stuff. In fact, we probably want to do that here too. We want on closed still. And then there we have it. So we don't want to run this twice for some reason it connected twice. So there we go. And then we should probably do something that kind of tries to auto reconnect, but we'll set that up later. So here we go. So now he's automatically connected. This moving around still works. And then ready for the new stuff. So we cast our spell. Boom. We actually have the ghost pop up and a unit up here. So that's pretty cool. It's a big step into our game as far as that goes. So, and then that. And this is just all using our existing stuff, just with a little bit of cleanup. And we have our units popping up. So that's pretty cool, in my opinion. So we're looking at a little bit more game coming together. We're actually spawning units now. So this is pretty cool. So now we have kind of a pivotal moment in our game here is where we want to go next. So we can keep continuing the path of the game itself. We could build in sort of our AI. There's some stuff I want to work on as far as breaking down the level. So we have a lot going on here. So we have a lot to do. But if we wanted to kind of clean up a lot of code and get our test coverage being figured out properly, you can see some of these that are, we've got a couple of hundreds, a lot of 90s. I think we've got a couple of really bad ones. I think this one, the service test, which is not really even being used yet, so that's bringing down our average pretty low. We can actually help a lot with these two. So, but overall, we can do better, but it's better than nothing. And any unit testing is better than no testing, always. So, what I'd like to do offline too is I want to get our test coverage, like I said, way more where I want it. So, without further ado, let's close everything else. I want to set up a way to start. This is an unfinished test, so we can say tag with skip. And so if we test, we should get 3 skipped. Okay, good. All right. So we could do more unit testing. I think kind of what I want to do. Let's take a look at our game real quick. What I want to do is, I think I actually want to have sort of clicky click happening. I think I actually want to be able to start selecting things and interacting with our UI. I think it'd be kind of cool to be able to select a unit. So let's see how we can hook that up. So let's look at our input tools, battle pointing tool. So this is this here. So what we need to do, I think one thing we don't have is our, let's see here, mouse input source. I don't think we have a tool. Game input tools. Let's just see. We're just going to pointer down, trace B. So it's been kind of a fun weekend. I've enjoyed a lot of getting our game much more polished and just cleaning up the code. It was really good weekend cleaning up all this code, getting a lot more tests in here. I've really been slacking on the tests in some of these. So I'm excited to sort of build that out, get our test where we want them. So we are getting pointer events. Okay, that's cool. I like that. So one thing we can do, there's a couple of things that we have going on here. We have pointer down, pointer up, right up, click. We have mouse wheel. Okay, that's cool. We have that in place. Mouse input. So we have that tested. That's good. So okay, I think we're going to do our UI. And what we'll do is we need to UI manager. It's going to be an interface. And as always, extend space object. And what I want to do is I want to function register interactive area. And we're going to get a rectangle. Rectangle. And I think that'll be fine. And then unregister interactive area. I think this will give us a uint, and this will do our key uint. So we'll do this is registers area on screen and returns interactive area key to be fetched or removed. Okay, and we'll just copy this one here. It's somewhat easier to do this way, I guess. Accepts interactive area key and unregisters area to be interacted with. Okay. Now we can say here, let's say we're going to get interactive area, and this will give us returns area of interaction. From key. Returns null if key is not matched. Okay. We can get all interactive areas, and this will return a array of rectangles. It's the worst. Returns an array of all interactable areas on screen. Okay. So this is just managing the interactive areas on screen. It's a pretty simple job, but it's I want it to be very simple. So now we need to create, I thought we had, yes, we have collections. And what we need to do is we need to build out a index of the interactive areas on screen using a quad tree. And a quad tree node. And we're going to give it a quad tree node we just have to build this out. Why not? Okay, so create a new, so hexlib run imunit create collections quad tree node test and quad tree test. So we have some tests for that. Uh-oh. Boom. Alright. Shouldn't affect much. So we're going to run our mock, all our standard stuff here, and then it's our quad node, and mock, we're going to need this pretty bad here. So 2 faileds. Quad tree node. So quad tree is, if you're not familiar, I'm open up a file here, and we're going to do toolbox new is as you break up the screen into a square, and then as you add points of interest into an area, since it's too bigger, so we'll just add more. So once we add so many things to an area, we're going to need to break it down into a smaller set of squares. So, like that. Okay? And so now, instead of trying to index the entire screen, we just have to find out which area of the screen that we're interested in and just query that part of it. And let's say for the example, this one, there's too many in here, so we can break this down even further. And we do want to set a depth, and so that you can find things quicker. We don't want to have too much depth to these things. So, and we also have to solve for if something sort of straddles, like in the middle here, its bounds, that it can be found in every case. So it's kind of our weird case. Changes, and here we have it. So we're going to have our quad tree PRV quad tree and what we need to do is to say test should be able to index a single node. Okay, and we may not want to test the node, but one thing we'll need is we'll need a rectangle. So it's the area it occupies, and we'll need its data. And we know that for sure. Okay, so we're going to set up, let me say, quad tree equals new quad tree. And we're going to say quad tree, we'll say, yeah, add. And we're just going to add some data. So we can use a node here, or we can actually just pass it the rectangle and the data, which is just going to be that for now. In fact, we'll just do var data equals this, and there's data, and then rectangle equals new rectangle. This is not what we want. Go away. And we're going to have, oh, one thing we need to do is we need to set the dimensions of the quad tree. And that doesn't change. Total width, this is going to be a uint, and total height, that's also going to be uint. So we got that. Public function add area rectangle and data dynamic. There we go. So here, I believe we have a constructor, yeah. We're going to set this up as 200, 100. Okay, so it's actually on the screen. And then we want to set the width and height, we'll say 20 by 20. And we'll do is a quad tree get item at point. We're going to pass it a point, new point. So here, we're going to go to public function get item, and we could potentially have overlap. So we'd probably get items at point. And here's our point, and we're going to return a array of quad tree node, and that'll give us our thing. So actually, I want to do this. I do want to make this a quad tree node. Quad tree node, and I'm going to return it. Quad tree node, return null. So get items at point, and this will give us our thing. So if we want to do, when we do 125 and actually 225 and 215, 110. That puts us in there. Say for items going to be an array of quad tree node. And then here, we're going to say area, rectangle, data, dynamic. Make these null if we ever wanted to. And then this dot changes to area, area, this dot data equals data, and assert are equal 1 items dot length. We also want to do new quad tree node like that. One thing I don't like about this is that we hold a reference to this, and we can just move the rectangle around, and that's dangerous. Don't like that idea of being able to have access to the rectangle. So I'm taking that back. I don't want that. So add and so we're going to return as a never actually use them very often anyways. Can we return a tuple? Unnamed immutable tuples for hacks. Let's see here. Because it'd be interesting to return the data as so one thing we could do, we could go back to having this in quad tree node, knowing that it'll be making a copy of it, which I kind of like. I'm okay with that. I don't like the idea of being able to change the area underneath it. I want to force us to use the quad tree. So, that being said, change the data we want, that's okay. So, we'll just make that as part of our tests. So here, we're going to say new quad tree node, rectangle. Actually, I could probably just do this then. Rectangle data. Yeah, darn. Just to rebuild the nodes on the get point. So it's okay. I'm okay with this. So this will give us a quad tree node. The length is okay. Assert so var node quad tree node equals new quad tree node. So we rectangle data node. keep going back and forth on that. And maybe it's better to not return the node, return the data. Kind of like that idea. So send in the rectangle and the data. There we go. I'm happy with that. Oops. B. So area, rectangle, data, dynamic. I like this API better. And this is going to return the data. And this is going to return the data. Because the rectangle will change. In fact, we can say public function get rect for data. And this will give us the rectangle. I'm okay with that. Really okay with that, actually. I promise. So, assert our equal, our data, and items at index 0. So this should fail gloriously. And this is quadtree node. Quadtree node. And it fails, so as we wanted. What we could do to here, we could probably return that, have it not fail, or not crash anyways. There we go. So there's our actual failure. Expected there to be 1. So what we need to do is we need to private var total width. We need to store that. Unit total height. This total width. This total width. And this dot total height equals total height. And just thinking of the API here, so public function get all data, and this will return an array of dynamic. And so this is a very expensive process. Very expensive. Has to traverse the entire tree. Okay. So now we're just going to clear out this one test and call it a day. And so what we're going to do is we're going to do should add. So we're going to say PRV, we'll call this our index. Right now we're just going to do an array because we don't actually know how we're going to store this yet. And this is going to be a quadtree node. index equals that. And actually probably need to do, yeah, okay, that's fine. Quadtree node, we need to do add. So I'm going to say var node quadtree node equals new quadtree node. I'm going to send it to area and the data like so. I'm going to return our data. I'm going to say index push node. Okay, and so now I'm going to get the items at the point. We're going to say for items and index, item and index. Right, is that build? Okay. Going to say var rectangle equals item dot area. Rect contains point, and that's going to be the point. So if call this var val array dynamic. It's going to return val. Val dot push item data. And we're all passed. There we go. So that's the idea. We're going to continue on to this tomorrow. Our quadtree node, we need to make sure, I'm actually going to write that test really fast. Quadtree node test is here. Test should create a new triangle, or new rectangle creation. var node quadtree node. That is the var data equals this var rectangle. Rectangle doesn't really matter. I guess we can do 1, 2, 3, 4. New quadtree node, and this is going to be rect and the data, and assert equal tree node data. Probably should be this way. Okay. Assert not equal. This would be our rect and our tree node area. I have to assert that these are equal. So 1 tree node area x, y, width, height, 1, 2, 3, 4. So here's our fail. Quadtree node equals new rectangle area x, area y, area width, area height, and that'll pass. So that's it for the day. All the stuff I've made changes to, that's all on GitHub. You guys can take a look at it, critique it, open bugs, give feedback, and play with it, whatever you want to do. Tree node test is 100%, quad tree test not, but that's okay. We'll get them there. And so that's it for the day. Happy coding. I'll see you guys tomorrow.